Hello, my name is Nuva Brewer, and today we're going to be talking about ways to solve Pascal triangle questions. The way this is going to work is that I am going to discuss the topics and the lesson, and there's going to be a small blurb on the side explaining everything if you can't understand what I'm saying. So the first thing we're going to talk about is drawing roots. This is the first way we're going to be learning to solve these kind of questions. So the main idea behind drawing the roots, as the name suggests, is to draw every single possible root by hand. This may be a long and very tedious process because you have to think of all the ways to get from point A to point B. You sometimes may repeat yourself and think you have more ways than you actually do, and sometimes you might not have enough. So this is a last resort and should not be used in all questions. This is only to be used in questions that are simple and questions that don't require you to do much work, because as the questions get more complex, the game gets much harder. So again, last resort, if you don't understand any of the other principles and if you don't have a calculator, use this. So an example question would be, Jessica is at point A and wants to go to her best friend's house, Thomas, at point B. How many ways can she travel there? Draw out all the possible routes. So Jessica is at point B at 8th Line and Whisper Street, and Thomas is at Walrus Avenue and Masters Road. So to do this question, I'm going to use the drawing routes method. So this is path 1, path 2, path 3, path 4, path 5, path 6, path 7, path 8, path 9, path 10. So to be exact, there are 10 ways to get from point A, which is Jessica's house, to point B, which is Thomas's house. And this is the drawing routes method. The second way to deal with Pascal's triangle question is Pascal's triangle method. Using the Pascal triangle, as the name suggests, you move forward or down the triangle. To get the amount of possible ways to get to a certain point, you add the two possible ways for the paths above it, and adding those two together gives you the total possible ways to get to the point. So this is the faster way than doing routes, but it's not as fast as a calculator. But unlike the calculator, this is very useful in all circumstances and all restrictions, regardless of anything. So an example question would be, water is flowing from a pipe and hitting a bamboo shoot on hinges. The water can either flow off of the right side or the left side of the chute. Two chutes fastened to the wall in the same way. There is a pool beneath them. How many ways can the water reach the pool? Using Pascal's triangle method, I'm going to show you the different ways to get to the bottom of the pool. So here, the water only goes one way. And here as well, it can go to either one way here or one way here. So again, in the third row, one way and one way. But here in the middle, there's two ways because it can come from here or from here. So I am adding the top two to get this one. So here, again, one way, but at this point, there's two ways to reach here and there's one way to reach here, so it becomes three. And same here, and again, one. So you're kind of getting the gist of it. And one, one, four. I'm just speeding up because you probably get it by now. Four, and here there's a six. And so one, one, five, five, there's 10, 10, and then 1, 6, 15, 20, 15, 6, and 1. So I'm going to add the bottom ones all together. So 1 plus 6 plus 15 plus 20 plus 15 plus 6 plus 1 equals 64 total ways. So that's question number A. So part B says, how many ways can the water hit the pool if the water can't go to the chute marked with an X? So that chute is right here. So not much changes up until level 3, level 4. But here, instead of being a 6, it becomes a 0 because the water can't go here. So that changes this spot. So instead of being a 10, it becomes a 4, and again, 4. That's about it in this level. And then in this level, these two and these two stay the same. And this one, and this one are affected. So instead of being 15, it's a 9. And again, instead of being 15, it's a 9. And in the middle, it's an 8. So 1 plus 6 plus 9 plus 8 plus 9 again plus 6 plus 1 equals 40. So in total, there are 40 ways to get down to the pool beneath all these chutes if water cannot go into the chute that's marked with an X. The last way to deal with Pascal's triangle questions is the combination method. So just use the calculator or the n choose r formula. The n represents a row number and the r represents the term number in Pascal's triangle. And this does not work unless you know the term number or if the question follows the Pascal's triangle, like directly. If it doesn't, it's not going to work. So an example of a question using the combination method is, how many ways can checkers piece move to row 5, term 3? So I've already done it for you, but basically n is the row number and r is the term number. So if the 5th row, right here, and the 3rd term, which is right here, based on where you counted from the left or the right, and using this function, which is c, which is choose, and t equals 10. So there's 10 ways to get to row 5, and term 3. Thank you everyone for listening. I'm sorry I rushed past some examples, but I explained everything that you need to know, and I sped up some of the videos so my voice is a little bit higher pitched than it actually is in real life. And again, thank you for listening.